morning everyone. My name is Alex, with double quotes, and you may be wondering why are the double quotes like that. It's very simple. A few years ago, a couple of journalists referred to a blog post I wrote as a blog post by a hacker who goes by the name Alex. Alex is also my real name. So this is my hacker name now. I'm so sorry. Also, I'd like to address this. A couple of years ago, some journalists wrote about me and they called me a hacker in double quotes. So this is getting out of hand. And also, for everyone who, people often come up to me and ask me, oh, so are you going to hack any more prime ministers? Are you going to go after any more celebrity boarding passes? It was one time. This is not my regular thing. Okay, addressed. Let us all move on. I also used to help out with this conference called PurpleCon, which is a conference just like this one, except instead of looking like this, it looks like this. And we did that because we thought that hacker culture had always been about rebelling and doing your own thing, and we kind of saw that everybody was sort of rebelling in the similar way like this. So we tried to rebel in some different way, like this. This probably had a lot of rippling consequences, and I'm not really exactly sure what they were, but it was really fun. So professionally, my job is that I work on the red team at Atlassian. And before that, I used to do the opposite of that. I used to catch people like me. And I hear you asking, what exactly is a red team? What exactly do you do there? It's very simple. There are 3 steps. Step 1 is we try and hack Atlassian, exactly like a real hacker would. We try and do the same techniques. We try and do it as fast as they would. We try and make it as realistic as possible. Then we share everything that we did with Atlassian. We write very, very detailed confession letters confessing to our crimes, because a real hacker wouldn't tell you what you missed. And then finally, we sell the stolen data on the dark web for big money, and no, not really, we didn't do that last part. One time I did this exact same slide at work, and there was some glitch, and the big red X didn't come up. I was like, you got to believe me, but no, it's fine, it's fine. But today I'm not talking about any of that stuff. Today I'm talking about this new thing that we're doing at work called Icarus Labs, which is where people come and do security research for 3 months, people like me. And that security research is kind of very vague. It's kind of meant to be anything that advances the state of the art. It's anything that's new or whatever. And part of the reason it's named Icarus Labs is because we want them to do something kind of ridiculous and have a lot of hubris and try and do something really ambitious. It's okay if they fly too close to the sun or whatever, but we want them to try something ambitious. And so this is about what I did in my first 3-month rotation for my research project. So it all started when I was talking to my teammate, and they said, what do you think it would take to not get caught for a year? And by not get caught doing what? Allow me to explain. What I mean is we have malware on someone else's computer, so we write the malware and somehow someone runs it on their computer, and it keeps going, it keeps running for an entire year. And also, obviously, they don't notice that it's there, because if they noticed that it was there, they'll probably remove it. So we want to, and I was like, wow, that's pretty hard. Usually you don't last an entire year on someone's computer. Usually you kind of finish up earlier than that. But what if you did want to do it for a year? What would you have to do? I don't know. How would you do that? And also I should specify that for this particular talk, we're talking about macOS, because those were the kind of laptops that we were I don't know, that's what we were just talking about. So that's what I ended up trying to investigate. And so I was like, how am I going to do this? A year is a long time. Maybe, I guess I could try and look for something in macOS that would be easy to hide malware in, but kind of everyone's already done that. Maybe I should look for something in something else that's people install on their computer after they get macOS. This is actually going to be really hard. So I thought about it for a while. And I was like, actually, I realized that people don't actually have macOS just like they bought their laptop fresh out of the Apple Store. That's not actually real. What happens is they go to the Apple Store and they get this kind of beautiful, pristine, fairly well security engineered computer, and then they're like, well, I want to develop software though. So I better install Homebrew, and I better install this cool shell, and I better install iTerm, and I better install Docker, and I also have to install the Xcode tools, and I have to type my password a lot of times. This is probably fine. And I realized that why would you try and hack this thing when you could try and hack one of these things? Because these things have way, way, way less security review going on in them, and they're extra things bolted onto macOS. People can configure them. And I was like, yeah, this is a good idea. I should try and find some way to hide malware in one of these things. And I was like, well, which one? Which one should I put it in? Well, I asked myself, which one of them executes code? And then I was like, well, actually, they all execute code, so I guess any of them. But I ended up picking Docker, because I figured Docker had the most features, it can do the most stuff, it can run anything, and also it's really, really popular. Everyone has it because everyone needs to run Docker. Well, everyone who's a developer, that is, has it because they all need to run Docker. And so it's most likely to work if you're trying to hide on someone's computer for a year, and they're a software developer, they're most likely to have Docker installed over any of those other things. And so then I was like, okay, I better start doing this. And you may be wondering, what is Docker? How does Docker work? I don't know, actually, really, how Docker particularly works. It seems really complicated. How do you use Docker? I do know a little bit about how to use Docker. I know that in the old days, when you wanted to get somebody else's code, you would use Git, and you'd be like, git clone, give me the other person's code. And that was it. It was great because you could get someone else's code on your computer. But what if you want to run the code? Then you have to be like, well, okay, I better read the README, and I better do whatever thing they say to run the code, and I better install the requirements, then I better be like, no, actually, that's the wrong Python version. This is really hard. Okay, that's kind of annoying. So with Docker, it's meant to fix that problem. It's meant to be like, I'll just run somebody else's code, and it will just work automatically because it includes not just the code, but the environment, like the dependencies and the operating system and whatever that they ran it on. So it will just work the first time. How does Docker work? Let's talk about it a little bit more. I don't know, actually, really, it seems really complicated. But some things about it that they keep saying is, I know it's not a virtual machine. Docker does not use a virtual machine, no. Who would do that? It actually uses things called containers. And you may be asking, well, what are containers? According to everything I can find on the internet, they are a lot like a virtual machine, except I swear they're not. They're actually different because they use your real hardware, not like virtual hardware. So like in a virtual machine, you have like, oh, well, here's your virtual CPU and your virtual RAM and all that. But in a container, it just uses your normal CPU and RAM, and it kind of mixes with everything else. It kind of uses your real hardware, but still the processes and files and stuff are separate, and they can't see your real hardware. They can't see your real computer. But also, I don't really know. It seems really complicated. So then I was like, well, how am I going to do this? Now I vaguely know what Docker is. How am I going to find this? What do I even do? I guess I decided I want to try and hide malware in Docker somehow. So I decided to just Google, hello, please give me something to read about Docker, really just anything. And then I was like, cool, here's some pages. That's actually a lot of words. Boy, I regret that. I don't really want to read all that. Jeez. And it just keeps going. And so then I was like, well, I don't know. How hard can it be? So I just searched the page for exec, because I was like, surely something executes code or executes something somewhere. I don't know. That's what I want to know about. 22 results, let's go. And so then I was like, oh, cool. And I scrolled around, and very quickly I found this thing. So to be very clear, I don't super exactly know what this is about, this runtime environment thing, or what this config file is about. But what I do know is it has this thing. It has some path to some file on your computer, and it's saying that I can put any file I want there, and then Docker will execute that file for me whenever it runs, because it has some sort of runtime configuration. Sometimes people want to provide their own custom Docker running things. I don't know. But the thing that I've learned is that there's a particular path on my computer, and if I put a file there, such as, I don't know, malware, Docker will execute it. And also, I can change that path to be whatever I want, and Docker will still execute it there. This is great. This is like malware persistence for me as a feature of Docker. Thank you. And then I was like, okay, this is very good. I need to investigate this right now. So then I was like, wait, but what file should I put there? Maybe I should put malware there? Yes, no, I will do that. I'm going to do that. And so then I was like, cool. I've replaced it, so it's now my malware is there instead of whatever was there before. Then I was like, well, I did. Okay, here we go. Time to test it out. And so I decided to run Docker, do Docker run hello world and just see what happens. And I ran it, and it did not like it. It was immediately like, no, Docker has to reset to factory settings. You have gone and broken everything. And it turned out that thing that I was replacing with malware, that thing actually did something. It actually helped Docker execute something. And so I replaced it with just malware, not whatever it was supposed to do. And then Docker gave me this error, and I was like, that's actually so reasonable. That's fair. I'm so sorry for bothering you. I'm alone with my computer apologizing to Docker. It's fine. So then I was like, okay, what is this? Maybe I should learn what this actually is, and maybe it still needs something to work, so I should probably let it work and also have malware. So I was like, what is this? My runc replacement? I don't know what runc is. And so I looked it up, and it's I wanted to know, what is runc? I assumed runc was what I was trying to do. I looked it up, and it's some nerd thing on GitHub. It's about, I don't know, computers and Golang and containers. I don't know what this is about. But the important thing is it's open source, because it's on GitHub. And I was like, oh, I love this for me. This is excellent, because I can just get the source code and then modify it to do everything it does normally, but also download and execute this malware that I had before. So now it does what it's supposed to do, so Docker will actually work, but it also does what I want, installs the malware. We already talked about it. And so I made my new version of runc, which has this bonus feature. And I was like, this time it should work, because it does everything it's supposed to do, and I put malware in there. Everybody wins. Everybody's happy. Let's try it. And let me show you what it looks like. This is what it looks like when you run Docker, the normal version of runc, without any of my fun modifications. And this is what it looks like when you run it with the malware. As you can see, this is the same thing. And I'm like, ooh, this is good. I hope that I hope that my malware is also actually working, though. I hope it's not just done nothing. So, but then I looked in like the back end of my malware thing, and I was like, oh, it's working. I have a shell. It's happening. The malware's running. This is great. I couldn't tell that I was running the malware. Let's see what I can do. But then as soon as I looked at this shell that I had on my own computer that I was testing it on, I was like, wait, why am I running as root? I'm not running Docker as root, and my computer's not called Docker Desktop. Also, why are there Mac OS things in the top level directory, but also Linux things? And also, what is this? What is host mount? Where am I? I don't want to be here. I want to go home. And so then I was like, oh no, maybe because it's Docker, I'm trapped inside a container or something. Then I was like, no, that doesn't make any sense. I'm part of Docker. Maybe I'm trapped inside a virtual machine? Actually, it was much worse than any of that. I'm going to save you a lot of pain and suffering and just kind of skip to what I found out at the end. This whole thing took a long time for me to understand and also process emotionally, so let's just skip to that. Actually, what's happening is turns out the malware that I made was running inside a Docker service container. I don't know what that is. It's some sort of it's a container that's like part of Docker. It's not one that you run. And it's like the admin container or something that does all the internal Docker stuff. And if it was just that, maybe it would be OK, and I would have processed it emotionally much faster. But this Docker service container, for some reason, is running inside a Linux virtual machine on your computer. And that Linux virtual machine is then run by your normal Mac computer. So we have 3 layers of Docker babushka into this. And I hear you saying, really? There's a Linux virtual machine on my computer? OK, Alex, I'm pretty sure I would know if there's a Linux virtual machine on my computer. So let's play a fun little game where I install Docker Desktop, and you watch it, and you see if you can find the part where we install the Linux virtual machine. Let's just do that. So to install Docker, you use Homebrew, you do brew install Docker, except just kidding, no you don't, you can't do that. It's Docker, it's very special, and you're not allowed to do it the easy, normal way. You have to go to the website of Docker and look it up and click buttons in your browser like a caveman, and you have to pick which version of Docker, which version of Mac do I have, which chip do I have, and really I have to do all this. Just to be clear, on Linux you don't have to do any of this. It's just there. But on Mac you have to click on the buttons anyway, and then you checking the page, are there added any virtual machines here, please? There's no mentions of virtual machines, so OK, probably I'm safe. And then every time you install something on Mac, you have to drag and drop a thing into your applications folder, and the app shows you how to drag and drop. I find this very preschool, but this is how we do it. And then you wait a long time for it to do that drag and drop and let it copy. And then it pops up this thing, and you're like, whoa, OK, what's going on? You want privileged access. You'll be asked for your password. This is OK. You want me to have a password? Sure. You want to install a helper tool? I like helper tools. Yeah. This is probably OK. I'm into this. According to the best research I could do, this is fine. This does not cause some horrible security problem. It just needs to become root briefly to install something for macOS reasons. This is not the problem. Spoilers. And then now we're doing it. Now we're running the little whale in the corner, which is how you know you're doing Docker. And so now that's it. We did it. We installed Docker. Did you like it? Did you like the install process? Did anyone see the part where we installed the Linux virtual machine? I didn't see that part. And they don't tell you on the website. And they don't. If you look deep enough, eventually they will tell you. But it's not obvious that you're secretly running a Linux virtual machine. But there it is. It's here. If you look for your running processes, you see this com.docker.hyperkit thing. Hyperkit is a special, very small Linux virtual machine just for Docker. And you're like, really? Why? Why would someone do that? Why would can you not? Can you do this without installing a Linux virtual machine, please? And to answer that question, we have to answer one other question. It's very, very simple. The question is, what operating system does Docker run on? It's very simple. Docker runs on just one operating system. Docker runs on Linux. That's it. That's the end. And in our grandparents' day, it would probably end here. But recently, there have been some other people who are like, well, what if Docker ran on Mac and Windows? I do my software development on Mac, or I do my software development on Windows, and I'd really like to run Docker locally. And so the awkward thing is that, it just runs on Linux, and it's a shame it doesn't run on Mac OS because we really like, and Windows, we really like that, but no. Docker requires features of the Linux kernel to run. It can only run on Linux because of operating system level things. It's not possible to run it on other operating systems. And I guess the Docker people were like, well, there's one way we could run it on Mac and Windows, I suppose, but you're not going to like it. We could simply put Linux inside Mac and inside Windows. We could simply get an entire Linux operating system inside a virtual machine on Mac and Windows for the sole purpose of running Docker, which is not a virtual machine, but now does require a virtual machine to run because it only works on Linux. This is good. This is fine. This is how we're doing things. This is how the world works. I was fairly betrayed by this. I'm sorry to have betrayed all of your trust as well, but this is the world we're in. And so another thing about this you may be wondering is that, well, usually, if I'm on someone's computer, I'm doing my cool malware thing, my malware is running inside this babushka container situation. Isn't this fine? Isn't this safe? Because like I'm inside my little container, and that container's inside a virtual machine. Those things are very separate. All the person's like secret files and stuff is up on their actual Mac computer. So like, how could I possibly get those things? I'd have to do like a Docker container escape and then a virtual machine escape. That seems really hard. Maybe this is fine. Maybe you can run your malware and it's in the service container, but it can't actually do anything. This is maybe not though. Maybe not. And so it turns out this is a great feature of Docker. There's a feature that they have called file sharing, which is just like, hey, what directories would you like to make available to this special Docker container? By default, it's most of them. And if you want, you can add any of them, and you don't need to be root or anything. So like while you're in the Docker container, you can just give yourself permission to do more things. So you can basically read and write and do whatever to any of the files on the host computer. So I was like, okay, that explains why there's all these Mac things inside this service container. That explains why all the Mac folders are there. Because this is a feature of Docker, is that your containers can read the files on your computer. And that kind of makes sense, right? Because if you don't know you have a virtual machine on your computer, you'd expect when you run Docker, you can see the same files on your computer because you think you're running on your actual computer. But secretly, they're very transparently like making it so that the virtual machine can see the real files, and you don't even realize because it's kind of smoothly done like that. And like, they're not hiding it. It's in the UI and stuff, but it's kind of not obvious. Like, it doesn't say virtual machine anywhere, Like, I didn't know for a long time. So I'm like, cool, the malware can like read and write files that are on the host computer, even though it's in a container. That's cool, that's sneaky. But what I really want to do is like stay caught for a year, right? I want to be sneaky, I want to be invisible. And so what I really want to know is, can the host, by the host I mean the Mac computer, can it see the malware? Like, can it see the running process? Can it see what the malware is doing? And so you might be like, yeah, well, why can't it? The problem is that all the host sees in terms of running processes is this. It doesn't see everything going on inside the virtual machine. It just sees one big virtual machine process, which is completely true. There is no process for my malware running on the Mac computer. Inside the virtual machine, there's a virtual process running the malware, but like, that's not real. On the host, there's this one big virtual machine process that has all the other ones inside it virtualized. And so, let me show you an example. If you were to run, here's some example malware that I made up. If you were to run this malware outside the virtual machine, and you were to check the running processes on your Mac, you would see these things. You'd be like, okay, someone's doing something, there's something to do with SSH keys, I probably don't want this running on my computer. But if you were to run the exact same code inside this virtual machine using this technique that I've found out, it looks like this. And also, this exact same process is running whether or not you run the malware. And like every Docker container that you run is also running inside this. Like this is like the shared process that everything to do with Docker runs inside. So it's hard to know, is there malware in there? I don't know. Like, you can't really see in there. And so I was thinking, oh, if they run PS to check running processes, they can't see it. If they check for running Docker containers, you also can't see it, because this is a special Docker service container that doesn't show up when you run. It's not like a special container you made. It's invisible. Like Docker hides it from you. And also, the antivirus or whatever can't see you because it can't see inside the virtual machine. This is great. We can do whatever we want. Let's go. And so this is like the beginning of my 3-month thing. Let's skip ahead several months of me trying to refine this and see what worked and see what didn't work and trying to add more features. And here's what we got up to. At this point, we made it so, yep, we can still read and write files that are on the host machine. We can also access the network. So if you're running commands inside this container, you are on, like, and you try and access the internet, you'll access the internet through this other, like, through whatever the laptop's internet connection is. Also, you can access the internal network. So if they're on the internal VPN or whatever, you are also on the internal VPN. And all that access will look like any other Docker container. Also, because it's part of Docker, and Docker keeps going when you reboot the computer or close the lid or whatever, it'll keep going. The malware will stay there if they restart the computer or whatever, which is great because we want to stay there for a year. And people probably will restart their Macs at least once a year, maybe twice. And critically, I added this feature that will prevent Docker Desktop from updating, because if you update it, by default, that will overwrite the malware, and then it'll be uninstalled. It'll still be running, but if they update it and then restart the computer, it won't be installed anymore. So I was like, well, I better not let it update. That's like a good Band-Aid solution to that for now. And also, I was like, well, what if you, at the moment, so far we don't actually have the ability to execute a command on the actual host computer. We can execute it inside this container, but we can't actually execute a command on the Mac because we're trapped inside this host container. And so I was like, okay, well, what if we really want to do that? Probably you don't have to. Probably you can do everything from within the container. But if you really want to, like, I don't know, kill a running process or something, I made it so I did this crazy thing where I like backdoored one of the Docker binaries so it has a shell inside it, but the shell is on localhost. And so from the container, you talk to this other binary, but it looks like normal Docker traffic, and it works. You can have a shell on the host now. But I figured that's a bit dodgy to like backdoor this binary and have it running on localhost and stuff. So I made it optional. So if you want to take that risk, you can, but you don't have to. So you may have noticed I talked about disabling Docker desktop updates. How does that actually work? How did I do that? It's very simple. Firstly, before we talk about that, this is real. This is a real screenshot of Docker. This is not a joke. This is not like it kind of is a joke, but it's not like Photoshop or anything. It says like, oh, hey, you have a new update. You can install it, or you can skip the update, and that's like pro, and that costs money or something. That's not how computers work, though. It's like, what do you mean? Like, you can't make me update the file on my computer. Like, if I turn off the internet, you can't update it. And like, what are you going to do if I don't pay you? Are you going to like hold me at gunpoint until I click this update button? Like, how does this? I don't understand what they were kind of going for with this, but okay, thank you, Docker, very cool. I was like stumbling around inside trying to figure out how do I like disable this. Oh, and so because we're figuring out how to prevent Docker from updating, I guess we're about to learn how to pirate Docker. Sorry, I guess. So inside the Docker app, there's this file called info.plist that I like stumbled on, and it has a whole bunch of fun left bracket, right bracket spaghetti like this. But the most important thing it has this thing called CF bundle version. It has this number, and this number is how it decides whether you're meant to update or not, it turns out. So the way it works is when Docker has an update, Docker says, hey, what's up? I've got this new version number. Is that higher or lower than the version number you have? If it's higher, then you should update and you should have my new version. But if it's lower or the same, then you already have this version number. Don't worry about updating. And so I'm sure you can see where this is going. I was like, well, what if I just surely it can't be that easy, can it? And it absolutely can be that easy. Because then when Docker tries to update, it's like, oh, sorry, you're good for several years for updates. OK, great. Maybe you should give me updates. Geez, OK. And I was like, well, that was easy. So sorry, Docker, I guess. I don't know. Yikes. What about detection? What about, I've made this sound so terrible, but is there a way to detect what's going on? Is there a way to know whether someone has done this to your computer? I don't actually know. That sounds really hard. So I was thinking, well, if you could check the running processes and see if the malware's... No, of course not, because you can't see the running processes. You can only see the one Docker virtual machine process, so that's not going to work. And I was like, well, what if you checked syscalls that the processes were making, and you could see if the malware's accessing your SSH keys, you could see that Docker was accessing your SSH keys, and maybe that's bad. But actually, no. Actually, a feature of macOS is that you can't do that. There's this thing called system integrity protection, which is no monitoring the syscalls of other processes. Even if you're root, you just can't do that. So that's kind of bad, because how are you going to know? How are you going to know what this malware is doing? How are you going to know if it's even there? What can you see to tell you the difference between there being malware and there not being malware? It turns out there's sort of a solution, which is this new thing that Apple came up with called the Endpoint Security Framework, which is this framework thing you can add to a macOS machine, which means you can see the syscalls now. Here's an API, which means you're allowed to see the syscalls that a process makes now. And so I guess the point of this talk is probably you need to use this if you're doing Mac security or Mac antivirus or whatever, because this is the only way you're going to be able to see anything to do with this technique, or I'm sure other people have done other similar techniques. What about prevention? Can you prevent this from happening to you? Can you make it so that someone can't install this malware in your Docker in the first place? Not really, no. I don't really know. I mean, there's one way to prevent it, which would be to not have Docker in the first place. But presumably you want to have Docker. You need it for business reasons. You need to run containers. I get that. But yeah, the problem is that there is a virtual machine on your computer, and virtual machines are really easy to hide stuff in. But also virtual machines are what allows Docker to work, because those people had a lot of hubris and decided that we should run Docker on Mac and Windows by running Linux virtual machines on Mac and Windows. So I don't really know what to do about that. And so I tried to contact Docker about this months ago, and I was like, hey, just so you know, here's this thing that's going on. This is probably a feature of Docker, but I just want to let you know, here's exactly how it works and everything. I'm going to publish a blog post about this, so here's a draft of the blog post. Let me know if you want to review it, if you have anything, if you want me to wait to publish it or anything like that. And they were kind of they were good. They did reply a couple times. They were like, oh yeah, we got your report. Yeah, give us some more time. Actually, by email, they didn't really reply. I had to find the I don't know, CTO of Docker on Twitter or something, and Twitter DMs is how I actually talk to these people. That's fine. This is professional. And they replied a few times, and they're like, oh yeah, cool. Maybe we'll try and fix this. Give us some more time. And I was like, okay, cool. I'm going to publish on this date. Let me know if you want me to do anything. And then eventually they were just nah, that's okay. And so I was like, well, all right, I warned you. So I published this blog post. And so if you want to know, they didn't sue me or anything, so I think it's okay. If I don't show up next year, you know why. And so if you want to know, I left out a whole bunch of details about this, and if you want to know if you want to know more details about how to actually implement this, just search for the name of this talk. There's a blog post about it telling you all about it. So in conclusion, Docker Desktop is a virtual machine. The hubris of build engineering knows no bounds. Thank you very much.